Hi students, welcome back again to an important video. In the previous video regarding to inequations and rules of inequations, now we are going to learn what is meant by replacement set and solution set. After finding the solution set, after finding solution of an inequation, how to represent that solution on the real number line. These are very important. We will learn all these in this video. Shall we? Now I have written the definition for solution set of an inequation and replacement set of an inequation. See, actually replacement set of an inequation is the set from which the value of the variable let x is to be chosen. Whatever the variable you may want to assume, it may be x, y or z. See, the value of the variable whatever you are choosing is to be taken. That set is called replacement set. And the solution set is the set of an inequation which is the subset of the replacement set. These two will be very clear when you take an example. Suppose I am taking a simple inequation, right, my dear students? Example, x is less than 3. X is less than 3 means you have infinite number of values which are less than 3. Now I am mentioning the replacement set. Replacement set, I will mention n, which is the set of natural numbers. Set of natural numbers. So if you write solution for this, you know natural numbers are counting numbers. I made a separate video for that also. You may watch that video. Natural numbers are the counting numbers. If you want take the values of natural numbers which are less than 3 means you will get only 1, 2 only. Okay, 1, 2. Then if you want to write the solution set, these they are clearly mentioning that replacement set is set of natural numbers. For this set natural numbers, if you want to take the solution set, there will be only 1, 2. Replacement set, they are clearly mentioning you have to take the set of natural numbers. Whatever the natural numbers which are satisfying this have to taken into count. This is the solution set. What I said, solution set is the subset of replacement set. 1, 2. Now I will mention replacement set as, okay, replacement set as W. That means W is the set of whole numbers, you know very well. Whole number starts from 0. So if you want to write solution set that is 0, 1, 2 only. This 0, 1, 2 is subset to this whole numbers. Is it or not, my dear students? Similarly, this 1, 2 is also subset to set of natural numbers. Then these are called solution sets. And this particular set we are mentioning the name of the set. Here also replacement set is W, means whole numbers. Then 0, 1, 2 is the solution set. We will have a lot of numbers in whole numbers, but we are taking some elements from that. Then that will become the subset. I made a separate video on subsets also. Please go through that video. And if you take replacement set as, okay, I am writing here, replacement set as integers, then the numbers which are satisfying this inequation will have lot of numbers are there. See, actually integers will have 0 and whole numbers positive and negative numbers also. So 0, 1, 2, we should not go outside to y because x values less than 3, and if you come to the left side there are infinite number of values, -1, -2, -3 and so on. So in this direction you don't have any limitation, infinite number of values are there which are satisfying this inequation, but on the right side there is a restriction, you have to go up to 2 only. These are the definitions of replacement set and solution set. I think it's very clear. Replacement set is a big set and solution set is a small set which is subset to the replacement set. We will simply mention what is the replacement set n. Whatever the values of n which satisfies this inequation is called solution set. Here I have taken n as my replacement set. Here I have taken w, which is whole numbers, as my replacement set. Here I have taken integers as my replacement set. But if you take replacement set as real numbers, then you have to write the replacement set in the set builder form. You know very well what is meant by set builder form. So R is equals to X such that, this is the set builder form. If you want to know very clear about what is meant by set builder form, clearly I made another video. Please go through that for better understanding of this. X such that X is less than 3 where X belongs to R. You have to write replacement set. Okay, replacement set is equals to X such that, you will read as X such that. In the set builder form you mention the property of all the numbers in the set and we will mention where it is coming from. See, X is less than means you have infinite number of values which are less than 3. That's why I am mentioning the property and where it is coming from. It is coming from set of real numbers. When you have replacement set as set of real numbers, you have to write it in set builder form. Now we will go how to represent the solution of an inequation on a real number line. Okay, representation of solution set of an inequation on a number line. For number line you are taking real number line. You know very well the real number line means it contains all values negative except square root of negative numbers. See, at the center I am taking 0. On the right side of 0 on the number line you have positive values. On the left side you have negative values. We may represent whatever the digits you want on the number line. That depends on our inequation. I am taking an inequation. Let inequation is 2x plus 6 is greater than 12. This is the inequation. You know how to solve this inequation by using rules which we were discussed in the previous video. So this is the plus 6. When you transfer it to the other side of the inequality, then it will become 2x greater than 12 plus 6 will become minus 6. Okay, my dear students, that implies 2x is greater than 6. Okay, x is greater than 6 by 2. If you want clear understanding of this, watch the previous video what we made recently. Okay, 2 ones are 2 3s are. That means x is greater than 3. If x is equals to 3, you can represent that exactly on the number line. That will become equation, but this is inequation. X value is greater than 3. So we have to show that reason which satisfies this inequation. So I am taking 1, 2, 3, minus 1, minus 2, minus 3, whatever the values may be. For representing this inequation, the solution of this inequation on number line, for our convention, for our convenience, we are using two symbols. The first one is halo circle, halo circle. Okay. The second one is dotted circle, dotted circle. These two will represent these two will give very important information on the number line. This halo circle represents that you you have to go up to that number only, and that number should not be taken into count. If you spot any number, if you if you spot any number on the number line with a dotted circle, you have to understand that the value goes up to that dotted circle and including the dotted circle. For example, in our case, x is greater than 3 means you have the values here. X is greater than 3. This area, this is infinite. But what about 3? 3 is there in our solution? No. Our x value is greater than 3 means 3 should not come into our solution. So you have to exclude. That means you have to write the hollow circle. Means the solution region starts from here, excluding this. Okay. When you have x, suppose x is greater than or equals to 3. That means x value is great and also equal. Means at that time you have to represent the solution region with dotted circle and you have to shade the region. You have to shade the region means that region, whatever the value in this region. See, you may have 4, 5, 6, 6.5, 3.06, whatever the values which are lying on the right side of 3 will come into our solution. Okay, this actually generally when you are having this hollow circle and the number line, that is used when only greater than or less than is there. And also when you see this dotted circle and the number line, you have to understand that it may be greater than or equals to or less than or equals to. In this way you may represent whatever the solution set of an inequation by using these circles. See, you have to understand by seeing the number line itself whether the value includes or excludes. Suppose I am writing on the number line, this is 0, minus 1, plus 1. When I am seeing one solution of one inequation, that's x is less than or equals to 1, you have to understand 1 is coming into the count or not. When you are having less than or equals to 1 is also coming into the count, and the values less than or equals to 1 means we want to get lesser values, you have to move left side, and you have to include this value also. Include means dotted lines, sorry, a dotted circle. So from this you have to go on to the left side. This region represents the solution region of this inequation. Whatever the value you will take here, that will satisfy this inequation. So you know that how to solve an inequation. After solving those inequations, you can represent the solution set of those inequations on the real number line, like by using this hollow and dotted circles. I think this video is helpful to you. If you like this video, if you think that this video is helpful, don't forget to subscribe to my channel and share it, like it to the persons who are needy of this type of videos. We will meet again in the useful video. Until then, have a nice day.